Jai Hind friends, I am Yogeshwar Kaha from New Catholic Mission School, Chhawa. Today we start the chemistry for 12th class student and our topic is application of Corrosion law. In our last video we already cleared about the Corrosion law and its first application. We have four different type of application. We already cleared in our previous lecture. First application, the calculation of limiting molar conductivity for weak electrolyte. Today we start the degree calculation, the degree of dissociation. Okay, and our second application is calculation of the degree of dissociation. Okay, a degree of dissociation for weak electrolytes. So degree of dissociation is equal to the ratio of the molar conductivity of given concentration it means C, and the molar conductivity of on given concentration, conductivity on infinite concentration. Clear? Infinite concentration, it means this. So degree of dissociation is shown by alpha. So the formula of degree of dissociation is alpha is equal to molar conductivity at given concentration and limiting molar conductivity, it means the molar conductivity at infinite dilution. Okay, and we know that according to Corrosion law, the limiting molar conductivity M is equal to the limiting molar conductivity of cation and anion. Okay, you know about the Corrosion law, the limiting molar conductivity of any electrolyte is equal to the sum of limiting molar conductivity of cation and anions. Done. It's our second application, calculation of degree of dissociation. What is the degree of dissociation? The degree of dissociation is equal to the ratio of the molar conductivity of on given concentration and limiting molar conductivity or the molar conductivity at infinite dilution. The molar conductivity on infinite dilution is also called the limiting molar conductivity and it's denoted by lambda m naught. So the alpha is a degree of dissociation. Alpha is a degree of dissociation. Okay, it's denoted by alpha is equal to the lambda cm upon lambda 0 m. Again we know about the Corrosion law. Lambda 0 m is equal to lambda 0 cation plus lambda 0 anions. So now we put this value in this equation, so we get it positive and negative. Clear? This formula we use in our numericals problem. Okay. Next application is calculation of dissociation constant. Okay. Next application is dissociation constant. Third is calculation of dissociation constant. Constant of a weak electrolytes. Okay, for a weak electrolytes. So Okay, now I consider one weak electrolyte example like that acetic acid CH3COOH is converted into CH3 acetate ion negative plus H plus ion. Okay, so now the degree of dissociation, I know that degree of dissociation is shown by alpha. So now we take initial concentration. So the initial concentration of reactant is 100%. Now I consider the only C. Okay. Then product concentration is 0. After some time, or final concentration is equal to the alpha. Now we show C alpha. Then here C minus C alpha. Okay. Now I know about the Kc value, the equilibrium constant Kc according to 11th class 7 chapters. Kc is equal to product concentration upon reactant concentration. So our product concentration C square alpha square upon C minus C alpha. So Kc is equal to C square alpha square upon we take common C1 minus alpha. So C cancel. Now the weak calculation of the dissociation constant. Now we show the dissociation constant by K. So our value of K is depend on C alpha square upon 1 minus alpha. So this formula we use the calculation of dissociation constant. Okay, it's our second application. I think you understand too very well. Now we take some example numerical problem. Then we use both of these applications in our numericals problem. Okay, I have one numerical problem. I written first, then solve it. Questions. At 291 Kelvin, the molar conductivity at infinite dilution. Infinite dilution, it means it say about the limiting molar conductivity. Okay, of NH4Cl, NaOH and NaCl are 129.8, 217.4 and 108.9 Siemens centimeter square. Its unit, the molar conductivity respectively. If the molar conductivity of a concentration solution of NH4OH is 9.33 Siemens centimeter square, what is the percentage? Okay, new word is come, percentage dissociation, but we know about only the dissociation constant. First we calculate the dissociation constant, then we calculate the percentage of dissociation constant. Okay, at this dilution. Okay, then also one more question is there. Also calculate the dissociation constant of NH4OH. Okay, first we read question, then solve it. At 291 Kelvin, so temperature is constant in our electrochemistry, so it's not useful for us. The molar conductivity at infinite dilution, it means it show limiting molar conductivity. Okay, solution is M, okay, of ammonium chloride, sodium hydroxide, sodium chloride are 129.8, 217.4 and 108.9 Siemens centimeter respectively. So I can mention here the limiting molar conductivity of NH4Cl is 129.8 Siemens centimeter square. Then NaOH is equal to 217.4 Siemens centimeter square. Then NaCl is equal to 108.9 Siemens centimeter square. Okay, it's given. Then respectively, if the molar conductivity of a concentration solution, concentration solution of NaOH is, so we have a given concentration, so I know about the CnH4OH is equal to 9.33 Siemens centimeter square. Okay, what is the percentage dissociation of NH4OH at this dilution? So I know about the formula of dissociation constant, degree of dissociation. Degree of dissociation alpha is equal to upon limiting molar conductivity. So I don't know about the limiting molar conductivity, but I have the given concentration, molar conductivity is 9.33. So first I calculate the limiting molar conductivity by the Corrosion law. I know about the Corrosion law. So limiting molar conductivity of ammonium hydroxide NH4OH is equal to the which? First ammonium chloride, because in this electrolytes we get NH4 ions. Then I want also one more ions, negative ions, OH minus, where NaCl and NaOH. So NaOH give OH minus ions, NaOH, and NaCl is not work for us, not useful for us. So we minus this values. Okay, now I put the value of ammonium hydroxide 129.8 plus sodium hydroxide 217.4 minus 108.9 Siemens centimeter square. So now I solve it. 8 and 4 12, then 1 10 7 70, then 1 2 2 4 and 3 1 2 plus 1 3 minus 108.9. Then I solve it. Then I got the values 238.9 3 centimeter square. Okay. Then I have now the limiting molar conductivity for ammonium hydroxide. So alpha is equal to, now I put the value of limiting molar conductivity at given concentration is 9.33. Then 238.3, okay, Siemens centimeter square upon Siemens centimeter square. So both are cancelled to each other. So the degree of dissociation unit is null. So now I solve it. So answer is 0.0392. But in the question, what is the percentage dissociation of NH4OH? And this is only degree of dissociation. So what I do, if I multiply 100, so it's converted into percentage. So percentage of percentage dissociation of NH4OH is equal to 0.0392 into 100. Okay, so answer is 3.92%. It's our answer. But answer is only for what is the percentage dissociation. So percentage dissociation of ammonium hydroxide is 3.92%. One more process remaining. Also calculate the dissociation constant for NH4OH. So first we understand about the degree of dissociation and I remove it. Then I solve calculation the dissociation constant. Okay. First I read full question and written here which is given by the question. Okay. Then second is our question asked about the percentage of dissociation. So I know the dissociation constant, degree of dissociation alpha. So I put here the formula of alpha. Then I see here this value is given by the questions, but this value is not given. But I know how to calculate this value according to first application. So the Corrosion law, I use first application, then put the value which given in questions, and I get it the answer of limiting molar conductivity of ammonium hydroxide is 238.3 Siemens centimeter square. Then I have both of value which used in degree of dissociation alpha, put the value and got answer degree of dissociation. But our question asked about what is the percentage of dissociation constant for ammonium hydroxide. So we multiply with our answer. So we get the percentage of ammonium hydroxide. Okay, I think it's clear it. Next I remove, then I solve for the calculate the dissociation constant of ammonium hydroxide. So I take here alpha value is equal to 0.0392 because I use it in next problem. Okay. Next, the calculation of dissociation constant. Calculation the dissociation constant. Okay. So I know the formula of dissociation constant. K is equal to C alpha square upon 1 minus alpha. Now I know about the alpha value. Then I put here C is equal to 0.01. Okay, M molarity. So now the calculation of K, C, it means 0.01 into 0.0392 whole square upon 1 minus 0.0392. You solve all of this term and get answer. Now first I convert it to 10 to the power 2 in scientific notation, minus 2 sorry, into 3.92 into 10 to the power minus 2 whole square. Okay, then here plus 2, okay, here also minus 2, then 1 minus 0, so 0.9608, then K is equal to, answer is 1.599 into 10 to the power minus 5. It's our answer for the dissociation constant. You solve yourself because already I solved it. Okay, done. Okay, now we start our fourth application, springly soluble solubility of weak electrolytes. Okay, now we start our fourth application of Corrosion law. Determine the solubility of springly soluble salt. First, we understood about the what is meaning of springly soluble salt. For like it AgCl. Okay, it's very low amount of AgCl is dissolved in water. So this is solubility is called springly soluble. AgCl and more example are BaSO4. Then one more example is MgOH twice are the example which is very low extent are soluble in water. So this type of solubility is called springly soluble salt. Then we have one formula for the calculation of springly soluble salt. The molar conductivity of springly soluble salt is equal to the kappa with the specific conductivity into 1000 upon molarity. Molarity. It is the formula of determination the solubility of springly soluble salt. What do you mean by springly soluble? Okay, if any electrolytes is very low soluble, very low, it means for weak electrolytes it's soluble. Okay, more less soluble from weak electrolytes, so this solubility is called springly soluble salt. So the example of springly soluble salt is AgCl, BaSO4 and MgOH twice. If you want the limiting molar conductivity for weak electrolytes, so use the first application, and if you want, so calculate limiting molar conductivity for less than 2 weak electrolytes, it means springly soluble salt. So you use this formula lambda 0m is equal to kappa into 1000 upon molarity. Thank you. Okay, now I think this chapter is complete. Because remaining portions like that battery are two types, primary battery and secondary battery. Primary battery is battery which use and throw, only one time chemical reactions is occur and remaining no recharge, so this battery is called primary battery. We use primary battery in watch, okay, in like that torch. So all are the primary battery, because in the battery which use in torch we use only one time, we use in watch we use one time and throw it. So this battery is called primary battery. Primary battery is based on Laplace cell. Okay, like that dry cell is the example of primary cell. Mercury cell is the example of primary cell. Mercury cell used in hand watch. Okay, small button like cell is called mercury cell. Then secondary cell, lead storage battery. Lead storage battery is a secondary battery. We use in more times. It means use one time, then again charge it, again use. It's called secondary battery. After, our last topic is corrosion. So you know about the corrosion. Iron is react with atmospheric gases and moisture, then convert into ferric oxides. This called rusting. Fe2O3 dot X H2O is a formula of rust. Okay, but according to CBSE, delete 30% portion from our previous syllabus. So the battery and corrosion and one more topic is there, electrolytes. Okay, so in electrolytics portion we have Faraday rules. Faraday give two rules. Okay, both are rules deleted, but you one time read it because it's very important for NEET IIT exams. Okay, thank you for watching this video. Jai Hind, Jai Bharat.